Okay, these are the notes for the quiz review, and I've broken the notes into two parts. When you take your test, there's going to be a no calculator part of the test and a calculator. Your quiz, however, is going to be all calculator, but I want you to see what kinds of things could show up on a no calculator and what would show up on the calculator so that you can have an idea and start practicing before your test. Okay, let's look at number one. So on number one, we have a division problem and the bases are the same. The bases are both 3. And so when it's division, to be able to figure this out, we subtract the exponents. And we do that, we don't change the bases, we just subtract the exponents. So this is 3 to the 8 minus 5, or 3 to the third, and 3 to the third is 27. Okay, number 2, inside the parentheses, you have those two things multiplied together, but outside we have an exponent, and when we do power to a power, we multiply the exponents. So for the x's, we're taking 6 times 1/3. So you can multiply straight across the top and straight across the bottom, or you want to reduce first, and we just get 2. With the y's, the y has an invisible 1, so I'm taking 1 times 1/3, which is 1/3. So your answer is now simplified, but we can't leave our answer like that because we have a fractional exponent. So x squared does not change because it doesn't have a fraction, but y to the 1/3, that we need to adjust. So the y goes into the radical, the 3 that's the denominator goes on the shelf, and the 1 that's a numerator goes in the exponent. That said, when the 1 is in the exponent, we don't need to write it. So that's a better version of what our answer should look like. On number 3, right now we got 1 over, well, go back into number 2. Anything we have to the 1/3 power is going to be the cube root. So if it's to the 1/2 power, it's going to be the square root. If it's to the 1/4 power, it's going to be the 4th root. The 1/5 power is going to be the 5th root, and so forth and so on. We need to recognize that. So in number 3, we've got a half in there. The problem is it's negative, and we can't work with exponents that are negative. So if something is negative in the numerator, we move it to the denominator. If it's negative in the denominator, we move it to the numerator. So since this one is negative on the bottom, we move it to the top, and when we do that, the exponent becomes positive. So now we've simplified, but we can't leave fractional exponents. So this is really 25 underneath, 2 on the shelf, the 1 is the exponent. So a nicer way of writing that is just the square root of 25, which is 5. Anything to the 1/2 power is the square root. You've simply got to know that part. Okay, so number 4, it's to the 1/2 power. So that means it's the square root of 121, which is just 11. Number 5 is a little bit different. Not hard, just different. We are multiplying those things. Again, the bases are the same. They're both 16. So the rule is that when the bases are the same, we're going to add the exponent. So we're going to have 5/8 plus negative 1/8, which is 4/8, but that's just really 1/2. So I have 16 to the 1/2 power, and we should know that means the square root of 16, which is 4. Over here on number 6, we're multiplying again. Our bases are the same. The bases are both y. So we never change the base. We just deal with the exponents. So since it's multiplying, we're going to add the exponents. So I have negative 1/4 plus 1/2. My common denominator is 4. So negative 1/4 and 2/4 would be positive 1/4. So I have y to the 1/4. So to the 1/3 power, it was the cube root. To the 1/2 power, it was the square root. So to the 1/4 power, it's the 4th root. Okay, now technically the numerator is right here, but when the exponent is 1, we don't need to write it. Okay, number 7, we're taking the square root of that number. Well, the square root of 49 is 7. And when the square roots are invisible 2 there, so we're looking for groups of 2. There are 4 groups of 2 and 8, and there are 5 groups of 2 and 10. On number 3, we're trying to simplify the radical, but on number 3, it's not a perfect cube, so we're going to have to make a factor tree. Well, it's even, so I get 2 and 28, 2 and 14, 2 and 7. It's a cube root, so I'm looking for groups of 3. The 2 goes outside, the 7 goes underneath, and we got to remember to write that cube on the shelf. It's just a half a point you lose, but if you forget it on all of them, that's a lot of half a points. Okay, number 9. Now we're looking for groups of 4. Well, in 14, there are 3 groups of 4. 3 groups of 4 is 12. That means 14 minus 12 is 2. There's 2 left over. With the B's, there are 4 groups of 4 in 16 with none left over. With the C's, there's 2 groups of 4, which means there's 8 C's. That means there's 1 left over. But again, whatever number's on the shelf has to go right here. So this is going to be a 4. All right, that is the first part of our notes. So again, the quiz is all calculator, but the test has a no calculator and a calculator portion.